This is the review for concept quiz 19. We're going to write an equation for each of the functions that are graphed below. So a quick review of what type of graph each of these is. Here we have a square root graph. This one is an absolute value graph, and then this one is a cubic. So starting with the first one here, the equation of a square root is y equals a square root of x minus h plus k. And for now we're dealing with graphs that have an a value of 1. So really we're looking at what is the locator point hk. On a square root graph, the locator point is right here, or where the graph is starting. In this case we have negative 2, 2 as the hk, and if we plug that into our equation we get y equals a is 1, square root of x minus h becomes x plus 2, and then plus k is plus 2. On the second one we have a absolute value equation. The format of the equation is a absolute value x minus h and then plus k. So in this case we have a locator point at 2, negative 2. And so if we plug that into our absolute value equation, a is going to be 1 again, x minus h, and then plus k is negative 2. And the third one, the cubic, will be in the form y equals a x minus h cubed plus k. And here our locator point, it's kind of hard to see where the xy axis here. So this is the y-axis, and we'll make this the x-axis. So in that case, for a cubic, the locator point is where the slow curve occurs. So in this case, this is at 1, 2, 3, 2. So positive 3, positive 2. Plugging that in, we get y equals a equal to 1, x minus h cubed plus k. In the second part, we're being asked to transform the function f of x. Let's go ahead and just call this middle one f of x. And we're going to transform it as f of x plus 1. So what this means is we're adding 1 to the x value in our equation. So if we do that, y equals absolute value. If you add 1 here, that's going to become an x minus 1. And then nothing happens to the k value. And we're being asked what direction will the graph be shifted. So originally it was at 2, negative 2, the locator point. Now the locator point is at 1, negative 2, which would be right here. So the graph is being shifted to the left, just by 1 unit. And if we sketch the transformed graph, the only point that you really need to be concerned with is the locator point. It's shifted to 1, negative 2. The rest of the graph will be the same. So we have here a slope of 1, so this will also have the same slope, and that's the transformed graph. Which of the following expressions could represent a function that has been flipped upside down? So you know from your study of parabolas that anytime your a value is a negative number, the graph gets flipped upside down. So in this case, the negative 1 multiplied by f of x would give you a graph flipped upside down. And then this last one, the graph of the equation y equals absolute value x plus 8 minus 2 is shifted 4 units to the left and 3 units down. What is its new equation? So easiest way to do these is look at the original equation and write down the hk. So in this case, this would be a negative 8 for h and a negative 2 for k. From the original locator point, we're shifting it 4 units to the left. So that means I'm subtracting 4 from the x value. And 3 units down would be subtracting 3 units from the y value. Then I can just do the subtraction and find the new locator point. This would be negative 12 and negative 5. And I'm writing a new equation, so y equals a is 1, x minus h becomes x plus 12, and then plus k becomes minus 5.